Hi, my name is Bret, and I'm from Radiant Vision Systems. So today we're going to discuss our TrueTest head-up display software package. We also have a photometer here. This is a Y16 with a 100mm lens, which uses autofocus and an electronic so we can actually measure the virtual image distance. This software package was developed with the help of SAE, Society of Automotive Engineers. We actually built this out for 1757-2, a safety standard requirement. We've also worked with several OEMs and their suppliers to build this comprehensive test package that uses different types of resources and different types of solutions for looking at dot distortion grid, ghosting, MTF, color, particle defects, etc. Let's go ahead and jump a little bit into the software. And what you'll notice here is that the software is going to communicate to the device. So it's going to place the correct bitmaps or patterns that you'd like to look at based on the characteristics you're looking for. So for instance, a white, maybe we want to look at particle defects on a combiner. Or for a 4x4 checkerboard, we're looking for contrast, the white divided by the black. So this is going to pass through a few bitmaps, and then we're going to go into a little bit more detail inside the software. But what you'll notice here is all of this data is being placed on the bottom half, so you can actually pass-fail based on different things like, minimum contrast, how big of particles I can see. So you'll notice here's a measurement of a 4x4, and then on the left side here we have our sequencer, so I'm going to run this. And as this kind of goes through, you'll notice that it's going to register the active area display. It's going to place POIs or run different analyses depending on what you set up here in the sequencer on the left side. And then the data is also available down on the bottom. So you'll notice some are red, some are green. Of course, green being pass, red being fail. And we're just going to let it kind of process here, and then we'll jump into each individual one briefly. So you'll notice first is the 13-point ANSI brightness, looking at color uniformity. Next we have the pixel defects or particle defects. Great benefit of using a high-resolution system. The next is a Ibox example, so we're looking to make sure that the active area is still in the eye relief zone. If a head were to move, then you could still see the active area. So we actually do a lot of communication with robotic arms as well. The next is a fail, so you can clearly see on the right side here that there's a missing part of the active area. Next we have ghosting, so if I zoom in here, you can actually see the real dot versus the ghosting dot typically created by a combiner. And then we have our contrast, so our black and our white, and you can see our points of interest being placed on those different regions. Next we have our MTF, so we're looking for the focus and the contrast of that active area. And finally into the dot distortion grid. So this looks at the neighboring distances between dots to make sure that we're not distorted. And what you'll notice is a few of these are red and a few are green. So like I mentioned, you can actually pass-fail, so you can set different parameters. For instance, here, minimum distances between rows or columns. Because we're using an electronic lens, we also have the capability to measure the virtual image distance. So instead of using a paravan, this camera can be coupled with the metrology side of it. Makes it very easy. So if I run this sequence, what we're going to notice is the camera's going to take a few images, the bitmap is going to be placed on the display, and then it's actually going to spit out the correct virtual image distance, and it's going to be on the bottom right there. And here is our virtual image distance. So thank you for your time. If you'd like to know more, please visit radiantvisionsystems.com.